Hi everyone, we continue the discussion of equations of lines and planes in 3D with one more example that builds off of this last example we did where a plane is defined in terms of two lines, and then we can define the point normal form of the plane from those two lines by creating a normal vector for the plane. The normal vector is constructed by taking the cross product of the direction vectors of the two lines, which results in creating a vector that's at 90 degrees to both of those direction vectors, which thus must be a normal vector to the plane. We combine that normal vector with any point on the plane, and that gives us our point normal form of the plane. The next question. There's another definition. So in addition to the point normal form of a plane, n dot x minus b is equal to 0, we have one more form of a plane, and that's the standard form of a plane. Ax plus by plus cz is equal to d, where a, b, and c are again going to be the coefficients from the normal vector. So a is equal to the first component of the normal vector, and 1. B is the second component of the normal vector, and 2. And c is the third component, and 3. And that d will again come from the dot product of the normal vector and the point on the plane. Actually, any point on the plane. So we'll go through an example. Write an equation in standard form for the plane with normal vector n613 that contains the point 502. So this n613 means that we have 6x plus 1 times y plus 3 times z equals d, where d equals n dot p. 613 dot 502. Just like in 2D, this shortcut comes from taking the point normal form n dot x minus b is equal to 0, distributing the dot product, bringing the n dot p and that dot product to the right hand side. And there you have it. So it's just from that. Okay, so let's do that dot product. 6 times 5, 30, plus 0 times 1, plus 3 times 2, 6. So we get 36. Plug that in. So our final answer is 6x plus y plus 3z equals 36. And it's worth doing a quick check. This time I'll write down the check. Does this plane contain 502? So if it contains the point 502, when we replace x with 5, y with 0, z with 2, we'll have left-hand side equals right-hand side. So 6 times 5 plus 0 plus 3 times 2 equals 36 with a question mark. 30 plus 6 equals 36 question mark. 36 equals 36 question mark. So true. That means it's right. We found everything we needed to find to answer the question. Okay, and then one more question to go through. We saw that we can define a plane with a normal vector to the plane and a point on the plane. We also saw we could define a plane with two lines that are in the plane. We can furthermore define a plane with 3 points. The way that we do that is we look at pairs of those 3 points. Let's say we call the points P, Q, and R. We could do Q minus P and to create one direction vector for the plane, and then do R minus P to create another direction vector for the plane. Now we have 2 direction vectors for the plane. We want a normal vector for the plane. So what do we do? Well, what we already did, we cross product them. That will create n. Now we have all that we need to define the plane in point normal form. N dot x minus p is equal to 0. With one caveat, one restriction, one thing that we have to make sure of, is that these 3 points cannot be collinear. They cannot be in a straight line. Because what will happen if they are is that when we do q minus p and r minus p, we'll get parallel vectors. When we take the cross product of parallel vectors, what happens? We'll get 0. 0 is not a very helpful normal vector for a plane. It does not help us define a plane. We get 0 times x plus 0 times y plus 0 times z equals n dot p. If n is 0, it's 0 dot p, which is going to be 0. We get 0 equals 0. True, but useless. So in order to actually define a plane, these 3 points cannot be in a straight line with each other. That's it. Other than that, they'll define a plane. Guaranteed. So the recipes down below create direction vectors that connect pairs of the points, cross product those direction vectors, create a normal vector, then you have everything you need to define the plane. So we'll do that in this problem here. So point P 103, Q 234, and R 225. Step 1, U is equal to Q minus P. Notice I'm changing these to lowercase p and q, because I'm doing that earlier in other videos, because I'm saying a vector is equal to a vector minus a vector. I don't want to say a vector is equal to a point minus a point. So it's understood that the little q with an arrow is a vector whose components are given by the coordinates of the point, big Q. Just a shorthand, just a quick way. So 2, 3, 4, minus 103. That is 1, 3, 1. Then v, the other direction vector, I'll say is little r minus p. And you can do it in the other order, p minus r. Or you could do r minus q. It makes no difference. I'm just going to pick 2 pairs. So 2, 2, 5, minus 103. So I get 1, 2, 2. Step 2, cross product. U and V to construct N. This looks a lot like the form where the plane was defined by 2 lines. So what we have? Make 2 copies, 1, 3, 1, 1, 3, 1, 1, 2, 2, 1, 2, 2, and then we'll cross them out. First and last. We'll have, I'll color code this one properly. 3 times 2, 6. 1 times 1, 1. 1 times 2, 2. And now the upper products, 2 times 1, 2, 2 times 2, 2 times 1, 2, 1 times 3, 3. Some commas in there, oops, almost missed the commas. So we get 4, comma, -1, comma, -1. And I'm going to do a quick check to make sure the cross product was done correctly. I'm going to take the dot of u cross v with u and v separately. So I'll do that really quick off to the side. This is just my check. So 4 minus 3 minus 1 equals 0. So that was 4, -1, -1 dotted with 1, 3, 1. Now I'm going to do the 4, -1, -1 dotted with 1, 2, 2. So 4 minus 2 equals 0. That's also true. So the cross product was done correctly. So that gives us our n. So steps 3 and 4. Thus, n dot x minus p equals 0 is given by 4, comma, -1, comma, -1, dot x minus, well, it says p, but you could use q or r. I'm going to use p. 103 equals 0. And there's one typo. I apologize. I just saw it. There's an extra comma in front of the 2. It doesn't make any sense. So you can fix that in your notes if you want. All right. So that brings us to the end of this video. In the next video series, you'll see calculations that are related to these. How to find the shortest distance between a point and a line, shortest distance between a point and a plane, how to find the point of intersection between two lines given in 2D. You know how to do that. I think you know. Solving two equations with two unknowns, that's how you solve the point of intersection. But how do you do it in 3D? And we'll also see how to find the point of intersection between a line and a plane. So, see you next time.